We are live for day 7 of Advent of Code. And yesterday's problem was an easy one. There's not much to review there. So what I'm going to do today is warm up on some past problems from the other year. One other year. I think I don't want to think too hard, so I'm going to do what I've done before. I think I'll do 2022 day 7. Should be about the same difficulty we're expecting, yeah? And yeah, I'll just save this as a new file, day 7 warm-up. And before I do that, we are going to make sure our file is ready. So what did we have? Day 6, let's save this as day 7. Change the input line here. Cool. And just delete all of this and pull up the problem. So how are we going to do this? Let's go to day 7. And I'll get my input ready for tonight. Yes, the directories. So we're given a bunch of commands. And we are moving around in directories. So we have some sort of state, and we are listing. And we get directories or files. And I think these are sizes of files. ls means list. cd moves in. Okay. Find all of the directories with total size of most 100,000. Okay, so I think we make a map, a graph representing it as a map. And this will be a directory to its contents. And then we have a size function to compute the size of a directory. And maybe this should be memoized. And maybe we have our own representation for directory here. I don't want to use a Java IO stuff. We get a list of directories. That will be the map. We turn it into a computation of sizes. Yeah, size should be memoized. So def size, and we have a directory name. And then just an int. Import collection.mutable.map. Actually, we don't need to import that. Just make a val of that type, and we'll call this size memo. I'm not actually completely sure we need a map, but we're gonna start this way. And maybe we should have a different type for directory name. I'm not sure yet. Actually, this is a file name. A file could just straight up have a size. And what if we skipped making an intermediate structure altogether? Actually, no. We do have to. Okay, so we go through these commands. Let me pull them up. So we have day 07, 2022. Oh, this is the example. Yeah, sure. Let's work with that first. Hmm. And then we have a directory map. It's like contents of a, so this is a map from a string. And then it's either the name of another directory or a file that has a size. Yeah, if we just represent like directory names with string. Cool. And maybe a directory or a path. Let's have a path. Yeah, a list of strings. We're going to be appending to the right, but that shouldn't matter here. And now we parse this. So like def parse. Um, but we have a current state. So we have our location, working directory, I suppose. Yeah, we'll call it working directory. And then we have a content so far. So let's just put this here. And then we have a line that we're parsing, and we're going to react to that and give us another directory map. In fact, I'm just going to save myself some typing and give us an alias here. Especially since we might be editing that. And then get another dir map. Okay, so we take a line and we match. And if it is a $CD, is it always CD to root first? Hmm. Is that even necessary? Can we just like start at root? And do we ever do that again? We don't even do that again. So I mean, like we could special case that. We could name it root. And if we have ls, then the next line, oh, then all the next lines. So we keep taking from the lines. Okay, so this is like the remaining lines then. Okay, so now we have to match depending on whether lines is empty. We're not going to do this line by line. We're going to get chunks at a time. So lines Bold. So if it's empty, we just return the contents. Otherwise, I think we just want the head option. Split by dollar. Yeah, I'm just gonna match it out of here, and we we're not really gonna split. The dollar's always gonna be on the left. There's nothing really to split on the left side. We're gonna do just the head option, or rather, I think it's clearer to say if lines dot is empty, then return contents. Then contents else. Now we, now we take lines dot head. Let's put that here. And now let's say we have an ls. Now we take the next few lines and we're going to span and take while it starts with a digit. So we're going to have like the remaining on the right side and files on the left side. And span by starts with, or rather, I don't know, head.isDigit. Sure. And then the files, we're going to split val size file name, or rather, we're going to just use a string interpolator here. You know what? The name might never be necessary. Yeah, it might not be necessary. And this list here, it's not just going to be a list of files. It's going to be a list of files or directory names. The name might be necessary if we're looking for the size of any generic name. But I'm not sure yet. So for now, we'll just keep all the information. And we take our contents and we have like a recursive call here. So we parse, working directory should be the same. Contents updated. Okay, it knows. Yeah, so we take the working directory. Working directory can't just be, this has to be a dir name. So working directory, this can be a path. In fact, well, yeah, we'll keep calling it working directory. So we keep the same working directory. A map from a list. I mean, I guess, yeah, fine. Lists are hashable too. Okay, we update directory with just use syntax for this. Wait a second here. This, we haven't matched it from anything yet. That doesn't quite make sense. So we're going to take files.map and then exactly this. We're not going to parse. So excuse me. We're going to turn this into size.toLong. file name. I'm going to rename this to file lines. Because these are the actual files now. And we'll turn this into collect. And then now we can have the recursive call with the updated map. Well, let's put that in a separate line. So new contents. W. I don't think I want to update it because that replaces, right? Yeah, that's a new value. Instead, we're going to do contents plus equals. Will plus equals work with this? No, contents WD. I think that's kind of wrong too. It's like plus equals, right? Let's just work with it. Doesn't seem to like that. Okay, we're gonna do this hard way then. Contents updated WD files. So these files all get added. Oh, you know what? You know what? We're not. It's gonna start off empty anyway. We can just do plus equals all the files. Yeah, that's what we're doing. Okay, this is a new map. Fine. So we had the same working directory, we had the new contents, and we just passed the remaining commands over. Great. And one of the remaining commands might be dir. Oh wait, sometimes these things are directories. Okay. So there is this here head is digits is it's wrong. So we're gonna do like head is not equal to another command. Oops. Yep, exactly that. There we go. And we have two cases. So this is the case if size.head is digit. So we'll put that in. So yeah, there we go. And then the other case is directory. In fact, you know what? We could put that first. Their name. And we don't even have to have this if match here. And again, this dir map becomes either a list of either just a string, I suppose. No, not just a string. We're gonna have a full-on path. Yeah, full-on path. Are you building the file system itself? Yeah, so this is Advent of Code day 7 from last year. I'm doing it as a warm-up for tonight. And I'll pull up the problem here. And this is our puzzle input. And apparently, you know, they have a file system that's full of too many files. So this here gives information about the file system. So I'm parsing this information basically and making myself like an adjacency graph telling you what are the contents of each directory. right? So I'm basically constructing this right here. And the question that's posed, the question that I'm going to try to answer here is at the bottom was a total, no, up here. What is the sum total of all the directories whose size is less than 10,000 or 100,000? Yeah. And this right here above means this is the size of a file, and then this is just a directory name. So yeah, I'm constructing this map right here. So this is either a directory, so we're going to say string, or a string and int, which is like a file name with a size. And that's these two cases right here. Although, maybe we should just make this a full-on path. There should be a path. So we're going to do our working directory and then append to the right this new directory name. Yeah, it's a crazier problem. I should post a link just in case people are curious. Um, and just so people walking in know, I'm gonna pin this. All right. Um, yeah, so we have the ls case handled. Now we need the cd case. So case. Oh, how did it know? Wait. There's no wait. It knew. It knew. Working directory plus. Okay, yeah, it figured out to do this. New working directory. Contents remain the same. And lines.tail. Exactly. Okay, yeah. Um, Copilot is pretty good. And with that, I think we can just parse the input. So the input is going to be a list of strings. Oh, wait, lines. Lines is not a string. This is a list of string. Yeah, okay. It seemed to figure out, or at least Copilot seemed to know what I was thinking here. And did that not give me errors? That's weird. Okay, so this size memo is a map from a path to its size, which should be a long. I'm using int anywhere. Anywhere it should be long. Yeah, day 7 looks crazy. You made that comment a long time ago. I don't know why that's so slow. I'm just gonna refresh this overlay and make sure it's okay. I don't know. This thing is going crazy. Oh my god. We're weeping all of this. Okay, that should stop going crazy. I'm gonna handle the CD root. But essentially, you know, this would just parse. And it would set working directory to list.empty. Yeah, contents are still going to be the same, and lines.tail, sure. And let's just straight up parse and see what we get. Parse starting with list.empty and map.empty and the input. well. There's some error in compilation here. Oh, nope, nope, that's the wrong one. Here we go. Oh, yep, yep. This is 2022. You remember this one? I remember doing this one. It was correct, and I was debugging for like an hour, and all this kind of code up here was correct. All the parsing, the building the JSON street tree, finding the size of a directory, it was all correct. I ran a lot of tests on it. I was so confused. It turned out the bug was in my answer computation at the end. I did a set.map, which once you map the directory names into file sizes or directory sizes, then it's no longer unique. And a map has unique values. So I was dropping values in my final computation. And it's just right there, a little one-liner. It was the last thing I ever thought to test. It has an issue here. I'm just gonna, okay, working directory. Contents are updated, but contents is a dir map. Okay, this has to be path. Okay, path goes to a list of other paths or a string along. New contents. Okay, new contents. This should be yeah, this is right. Did I like forget how to use a map? So we're updating our working directory with a new value. Oh, this is a list object in equals. This should be a list of either path or a string and long. I think I'm gonna change the order here. That matches what we're seeing down there. Okay, so this is a long or a string, right? Okay, we have a Stack Overflow error. Let's make sure our recursion conditions are working. So our base condition, if it's empty, we just return the contents. Otherwise, we match on lines.head. In this case, we take lines.tail, so it should be getting smaller and smaller. Here, we take the remaining lines, remaining being the lines that don't start with whatever, right? And span, this should take the left-hand side, rather the left side hand side should have this condition that the head is a character, right? Yeah. The head character is not the $sign. Okay. So remaining is also shorter. So we should be getting smaller every time. And otherwise we take lines.tail. So in each of those cases, we're getting smaller. Iterable once offset reduce left. Okay, so we have a lot of calls to parse. Yeah, so parse is in an infinite loop. I'm not seeing it. Are any of you? Let's print these one at a time. Yeah, let's just learn to debug, but print line, let's say lines dot size Okay, what did it end up printing? 1013. 1013 is what it starts with, and then we go to 1012, and we are constantly okay, so contents might not be changing. In this case, CD. Contents shouldn't change. I mean, I suppose, yeah, no, contents don't change at all. In this case, we do have a new contents, and it's that with files. And when we're doing the recursive call, we are using, okay, with ls, the working directory should not change. Okay, let's print more. Um, let's just do like a print of the working directory. Uh, make string. We're gonna make string with slashes. Okay, so we're staying at root. We're staying at hmm. You read about the name tuple SIP? Yes. Yeah, I haven't used it yet, but I saw it. I've read the discuss post on it. Yeah, I don't know if I have it here. That isn't 332. I don't know. Okay, so we are in fact staying in the same directory with each recursive call. Um, and for the same number, so cd whatever. Let's also print whatever the head command is at this point. Print lines.head. Yeah. So lines.head, and then we do take care of that. And then in the ls, we're ending up in an infinite loop. So here is where's our ls case? Right here. So file name lines, let's print the file lines just to make sure we're parsing the right thing. Oh, I should turn on like an option that just summarizes that. It is an empty list. Okay. Yeah, so we do the ls. Oh, hold on, hold on. We don't want all the lines because we're doing the line heads. The lines dot what is it? Lines dot tail. Lines dot tail we're spanning. Okay, so now that should work. We're gonna take these out. Okay, great, great, great. And then now we calculate the size of a file. So we have a size memo, mutable map, and then we do like a size memo, like get or else update. I'm not even sure if we'll end up looking at the same file again. So probably unnecessary. You know, my comments are showing up like really late, and I don't know why. Okay, I refresh things. Let's see if that gets fixed before the problem really starts. Oh my god, the problem's gonna start in 3 minutes. I mean, let's see if we can do this. So we get the size of everything recursively. So get or else update. Oh, this is a path. So we get hmm, um oh, and you know what? If we do this recursively, we're gonna end up calling it on either path or just a file name, in which case we don't quite have that yet. Um I think in here we need to sort through between them. So get or else update, and let's do like a block here. So we take the contents of dir map of file dot collect. Okay, so there are two cases. Yeah, okay, we're out of time. So if it's a path, we do recursive call. Okay, I'm done. I'm done. Let's comment this out so it's not bugging us. Turn off that alarm. That's a good thing we have it because I would have kept going. Um, Great. So we have our day 7 input ready to go. Let's close this out. 25 seconds. And let me see. I am ready. Let's do this. 10 seconds. I'm going to start this time by looking right at the input. Okay, a bunch of IDs and numbers. Oh, are those cards? We're playing card games. Camel cards. Okay, and I'm going to start by looking at the question. Let's put myself underneath here. Find the rank of every hand in your set. What are the total winnings? Ooh, ranks of cards. Cool. Um, all right. You bring the parts, blah, 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 blah. This is just flavor text up here. Figure out where the parts are stopped. Okay. So now she teaches us camel cards, which is similar to poker. You get a list of hands, and your goal is to order them based on the strength of each hand. Hand consists of 5 cards. Okay, there are no suits. The relative strength of each card follows this order. A is the highest and 2 is the lowest. Every hand is exactly one type, strongest to weak. 5, 4, full house, 3 of a kind, 2 pair, 1 pair, and high card. 3 full house is stronger than a 3 of a kind, sure. If 2 hands have the same type, a second ordering rule takes effect. Okay, I'm wondering. Oh, excuse me. Hey, happy birthday. Yes, thank you. Just Barrett, remembering my birthday. I don't know why the comments are showing up like 5 minutes late. Your comment will show up here eventually. Um, if 2 hands are the same, okay, yes, there's a tiebreaker. That makes sense. The first example shows 5 cards, followed by a bid amount. Each hand wins an amount equal to its bid multiplied by its rank. The weakest hand gets rank 1. Okay, and the rank is this stuff here? No, type is different. So this is a type. What exactly is the rank? The second weakest hand gets rank 2. Oh, rank of in the whole thing? So we have to sort the whole thing. Okay, so we can create a hand type with an ordering, and I think that's what I will do. So enum um, cards, and this will just be, we'll just use characters to represent cards. And we only have a few, so let's do 5 kind. Okay. This also has cards, right? So now we have 4 kind, autocomplete to the rescue. Case full house, exactly. Case 3 kind, exactly. Case 2 pair. Oh, yeah, all the boilerplate out. Case 1 pair, and case high card. Okay. And then we're going to define an ordering. Excuse me. This cough has come at the worst time, let me tell you. Um, so we're gonna do a given ordering. Oh, I'm blanking on new syntax. So for hand type, um, so each of these, we do a tuple. Okay, this sort of works. Um, yeah, we're gonna order by tuple. So I guess the best here is gonna be the lowest in this case. And then we still have to do something with the cards. So we need like a tie break. I think we might need to do like the direct comparison. I think in this case, well, let me see if we could at least have the correct ordering here. So is digit 1, for example, less than ace? And 1 is less than 2, sure. And then, well, there's king, queen. They're not gonna be in the right order. Um, okay, we're gonna have cards, and we're just gonna have to write card parsing boilerplate, but you know what? That's fine because we can write boilerplate. Okay, and do these have a natural ordering? So card.ace, or let's say 2 is less than card.3. No, so we need to give an ordering. So given ordering of a card, ordering that by, we don't need all that at all. I mean, it's correct, but we can just use the ordinal. And actually ace should be the top one. Wait, how do we reference a thing? So by card, the ordinal, uh, card dot ordinal from ordinal. No, no, no. To card dot ordinal, a method. Oh my god, this is this is stuff I should have ready, but I don't use Scala 3 on a daily basis. King is less than queen, sure, but I want to make sure it's right, and this will be okay. You know what we're gonna do? We're just gonna use the autocomplete here, but know that we could just use the ordinal. Okay, so now 2 is less than, or rather, ordering, or card.2 is less than card.3, for example. We need the ops. Import math.ordering implicits infix ordering ops. Here we go. And these all need to be cards. We're just going to import everything out of card. Import card.star. Or you know what we could do? We could do this. I don't want to dirty the namespace with all the helper methods from that. Okay, cool. It's working. It's working. And now this is in the wrong order. I have to reverse something. Yeah, this is the wrong order. We have key bindings for this. To pair up. Okay. And then these list of character are now list of cards. List character, list of card. Unused explicit parameter. What do you mean unused? It's right there. I'm gonna rename this to hand. And these are the hand types here. Excuse me. So given ordering of hand, order by rate. And then card itself has an ordering, so we can just pass along the card ordering. Cards.head. Yep, that has an ordering that works. And then this, in this case, I don't think ordering by is the right one. Let's try other approaches. Ordering dot apply just to create one. Yeah, okay, so it would look something. Then we can do the comparison between, well, the thing is, so we have a different ordering for each of these. What we could do is a list. So we're going to order by a list, right? And then it's like a list in order, all the tiebreakers. No. So not not by list. So we have this ranking, and then we have a list of cards. And a list of cards we can get an order for. Okay. And then in the case of four of a kind, we're gonna get the cards sorted. The one that has four, val quad equals whichever one appears more than once. All right. So I guess we don't need to sort. Let's sort. So cards that's sorted, and the quads are gonna be the ones that's in the middle. Cards and 0, 1, 2. Let's just take the second one. And if s.head equals quads, so this is a tiebreaker. If s.heads equals quads, then s.last else s.head. Yeah, exactly. Exactly. And this probably should be like a vector. We're gonna replace list with vector. List of card with a vector of card. Oh, no, we don't want that. Then s.last else s.head. Great. So yeah, here's our rank for the hand type, followed by this, which we'll be able to sort just fine. And in fact, we can do like this. So list card dot ace and let's check if that's less than list card dot 2 and card dot 4. To be able to derive an ordering. Not a member. I mean, I did do implicit ordering ops, right? There's an ordering. Implicitly, let's check if we have that ordering of a list of card. Do these have a I thought that could be derived. Let's see. Implicitly ordering a card. Yeah. So okay, I thought that was auto-derived. I'm gonna have to double check on that, but I'm still gonna do this because I know there's a way. There's a way to make that work. So full house. Now this will be the 3 of a kind followed by the 2 of a kind. So again, we're gonna do the trick with s equals sorted, val trips equals s2 exactly. And val pair, that depends. Kind of thing. I'm waiting for autocomplete to notice what I'm doing. Then s.last. Oh, actually, yeah, if s.head equals trips is the same thing, then s.last, you get the other thing, else s.head. Great. A three of a kind. If you have a three of a kind, again, we're going to do a sorted. Val trips is also going to be S2. And then we have two ties. Val. Okay, well, let's do I1 and tie 2, and we can sort those. Um, we'll do this. Then we have s dot last and s dot init dot last, second to the last one. Or you know what, we could make this more clear. Let's do s4 and s3. Otherwise, we have s0 and s1. This is like very hard coded. I'm sure there's like a clever way to do this. It's sorting something. I don't know. So we have three, and then we start with the trips. That's priority. Oh, what we're going to do is trips, and we're going to cons that onto list of T1 and T2 that's sorted. What order is that sorting going to take though? That reverse, right? If we sort like this is already sorted, and that's not what we want. That will show up once we fix whatever. And no list ordering is defined. Okay, I'm going to do some quick research here. So we had ordering before. Git ls files, xargs grep ordering. See how we used it last year, 2022. Which one of these? Ordering dot on. Oh, I could use dot on. Okay, well, it's too late now. What am I trying to figure out here? There was a list. Oh, day 13, 2022. Okay. Day 13, 2022. And here we took advantage of the list ordering. Oh, we just do an ordering.compare for the list. And then we have a compare method, recursive compare method. And we compare two lists of packets. Yeah, we can compare two lists of packets. Precisely because we have an ordering for a packet, right? And it even works recursively here. This is the definition of the ordering of a packet. It uses the definition of an ordering of a packet in order to give us an ordering of a seek of packet. So why can't we do an ordering? So import math.ordering, or actually no, wait. So let's just do an ordering of a seek of card. Like we should get this, right? It doesn't like that. The in this old one, So we have an ordering for a packet. We have an ordering for a seek of packets. Um, yeah. Do we get other types? So we get an ordering for a list of packets? Yeah. Okay, there must be an import in here. At the ordering that implicit is not given. Okay, that's probably what we have to do. What's all this stuff here? Okay. Import math.ordering.implicits and just all the givens. That should include the other implicits, the infix ordering ops. Okay, now this works. We were just missing an import. Um, I'm just gonna turn that to colon here. Okay, great. So whatever issue it has should be more reasonable now. No implicit ordering given for int and list or list. Yes, right. List of vector. Um, that's because somewhere here we had just a straight up vector. Oh yeah, list of all the cards. Yeah, that's not gonna work. We're gonna this should compile if we do that, right? So I think we just have to complete to keep working on this. And then we need to find the pair. And we could just do like a count. Yeah. Um, but let's still do it by sorting. In fact, you know what? The constructor here should just sort them to like normalize it. I don't know why I'm not doing that. In fact, like in constructing these, we can just construct it with the three of a kind has like the trips and or like full house will have a trip and a pair, right? Oh, and also these orderings are backwards. So we'll have to change that because we changed the ordering after after that autocomplete. So 4, 3, 2, 1, 0. I hope that's right. Okay. S equals cards that's sorted. We're doing like too much sorting here. Now P1, P2, if this is not right. Val paired equals we could just do like if else. Like we could sort it and then look for them. We could remove from the list until there's only one remaining, or we could do like a group by. Let's do this. Let's do group by cards dot group map reduce identity to 1 to plus, and this is the counts, and then two lists sort by two reverse dot map 1 and then dot head. That's what would come next. You don't need a reverse. I mean, sure, we could do reverse. That works. Now, yeah, and then we can just do like all the cards sorted. And we might need to do like reverse sortings. Card 2, 4, 3. I think I want to reverse in all of these. Yeah, we want to reverse in all of these. We want the big stuff to come up first. And I just spent time like reversing this. Okay, you know what? This is just autocomplete. Yeah, let's just have aces come first. Case, card.ace. Okay, now I have to do this one by one. And while we're doing that, maybe we can think about what's next. Okay. So we have an ordering there. This I just spent so much time waffling on this, whether I should have that first or not. In fact, I'm not even sure if this is, like the worth it way to do this now. Oh wait, yeah, we want the best one first. My card, one pair should be above that. Full of a kind. Full house beats three of a kind, and then two pair, one pair. Okay. Five kind is the highest, so that is good there. Group map reduce identity. There is a problem. Oh wait, yes. Counts. Yeah, let's just do counts separately. Well, paired equals cards, not find. Or no, counts dot find. Counts dot collect first. That matches case card 2, and we return that card. Okay, we got paired. And then we take the remaining cards. Remaining. In fact, we don't even need to collect that, right? We can leave that commented. Oh wait, no, it still has to be in our ordering. So we have paired card onto something. It's the remaining cards. Counts.collect case card one count, and then we just return that card. And then we take remaining that sorted. Oh, wait. This is two pair. Okay. So this is just going to be a collect. And paired, that's sorted onto a list of just the remaining. Yeah. Wait, remaining is already going to be a two list. Okay, that's good. Paired dot two list dot sorted, sure. And then one pair is the code we had just written earlier. So now this becomes a collect first. So paired dot get onto remaining, that's sorted dot to list, or to list dot sorted. And in this case, right here, we just sort cards. Cards dot to list dot sorted. I hate that we're sorting lists. These should actually be vectors, but whatever. Method select does not take more parameters. What do you mean does not take more parameters? Oh, wait. Yeah, we take all the remaining cards. Where are the parameters it's taking? We're not taking parameters, we're passing a partial function right here, right below on this next line. What's wrong with it? What's wrong with it? Okay, and then we sort all of these. Remove case. Well, I need the case because this is a match, right? We're matching against the case where there's a 1 here as a second value. Okay, so counts. What is counts? Be a map from card to int. Uh-huh. To list. So once it's a list, it becomes a list of card and int. Collect what's there. Recursive value remaining. Wait, it thinks that's part of that? Weird. Wait, was that it? Like this? It's an indentation thing? Okay, sure. And we have an issue here. No implicit ordering given for list, object, and equal. So one of these is not a list of cards. Okay, so this is a single card, right? List list of okay, you know what? We're gonna give this ordering, we're gonna give this a parameter here, and then we'll get ordering by int and list of card. Now the type error should show up down here. Okay. Found a list of card required just a single card. Oh, right. So this is a triple colon because we're concatenating two lists. Okay, that works. Do we have any other issues with it? Unused explicit parameter? Sure, that's fine. And now, now we do the parsing. So, val hands let's look at our input. Day 07, 2023. Okay. Yeah. So we take this line, val, and then we have cards and bid. Cards and bid. And what we're going to get here maybe I use a vector here. What are we going to do? We're just going to sort this. That's fine. So hands is going to be a list of vector card and an int bid. what's it doing here? We don't like that. Cards.map. Card.parse. Let's comment this out for right now. And we have to define that. So I do it right here. Character. And I am really hoping for Copilot to come in. There we go. Perfect. Oh my god, all the boilerplate gone. Up to vector. And then that goes to bid.toInt. Oops, bid.toInt. This equals line. Okay. So we have all the hands. There's some problem here. Okay. So we'll sort them. The best hands will show up top. We're gonna we're gonna reverse sort them. Zip with index. That will give its rank. Yeah, that's fine. Oh, not card.parse. We're gonna use parse card. Exactly. Whoops. Okay. So, what did we name this? Hands. So hands dot sort by one dot reverse dot zip with index dot map. So we have case exactly that. I plus one. I didn't know to add one. Okay. Bid times I plus one. Okay, great. In fact, we don't even need the cards. We could map this map. Whatever. That's still correct. So val hand scores. And then what was the question? Oh, and let's just make sure we do in fact. So hands dot max by one. What do we get? Ace, 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 five. Yeah, exactly. That would win, wouldn't it? Okay, the question is, find the rank of every hand in your set. What are the total winnings? Okay, so multiply and add. Val and one equals hand scores. That's sum. Okay, so, whoops, we have 2, 4, 8, 1, 6, 7, 1, 5, 6. 2, 4, 8, 1, 6, 7, 1, 5, 6. That is getting big. Perhaps we had an overflow. Well, oh, that's hundreds of millions. We have 4 billion, 2 billion. So let's do the example. Make sure it works on, oh, I guess this. Yeah. A7X. What answer did we get here? 8478. Okay, so not quite right. So 765 plus 1. We want to just print this part. So let's take No, we just want this tuple here. And then we're gonna do like a for each. And then we get print line. So the bid and the rank. $28 bid for rank 1. 765 should have rank 1. 220 should have rank 2. Okay, let's just take hands dot map. Just take the hand dot sorted. Let's do it for each print line. Okay. Oh, we don't need to do reverse because they are already sorted in the right order. Right? No. Let's check this. Okay, so when we sort them, we get 3 through 10. Okay, that's like a high card. The bottom one is 2 pair, kings and sevens. Oh, that is not in the right order. 10, 5, 5, jack 5, queen, 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 jack, ace. What should be the best one? So there is a 3 of a kind in here. So that is the queen, queen, queen. Oh, you know what I could have done? And I've done in the past before. So we sort these as we're building them. Then the queens will always be with each other, right? And then we match on those patterns that we see to determine what kind of thing it is when we're parsing the kind of hand. Oh, also, wait a second. These are not hands. We didn't convert them into hands. Right? We want a list of action hands. So we need to turn these into a hand. Yeah. Okay. We forgot to even use that. And this is a part where we could do the sorting. So hand, apply to that. Oh, we don't even know kind of what hand it is. Okay, we still have to like determine which hand it is. Okay. Def choose hand given a vector of card. Okay, and the hand does not need to have like the whole vector of cards. This could be like the card type right here. Right? 5 of kind, you only choose whatever. And we don't even need this thing anymore. Okay, we're doing more refactoring. We should have written this right the first time, but we didn't, so so this is just gonna have a single card. We weren't even thinking about how to parse this into that's a problem here. So we have card, and then we have like a tiebreaker. Oh my god, all this stuff we wrote down here in this ordering, that's gonna go to shit. Because we're gonna have a better way to do it. That's unfortunate. Oh well. So we have here, we have the trip and the pair. And then we have trip Um, and then we have a tie 1, and then a tie 2, right? 2 pair. We have pair 1, pair 2, and then we have the tie. And then we have pair, card, and then tie is just going to be a vector of card, and high card is just a vector of cards. The tie here is just a single card. Let's take out this type. You know what? We're going to do this a triple colon, and we're going to make it def so that we don't get any no compiler errors. So we have a vector of cards. Yeah. The cards that sorted match. Yes. Depends on where it's sorted though. No, we're not just gonna sort these cards. We're gonna group them and then additionally sort them by. So cards dot group map reduce. Okay. And let's see. To list dot sort by the group size. And that's good. That's good. So now card groups and card groups match. So that's exactly the kind of thing I was thinking about. So case vector card 4, card 2, 1. Yeah. We can do an ordering directly on a vector of card. We don't even need hand types at this. Oh no. We do want hand types. So 4 of kind, so that's card 2. Right? Yeah. Okay. Vector. And that has to be in order. So let's do a little magic here. Oh, you know what? Let's just give it a secondary sorting. Sort by. So what do we have? Card and then count. We're gonna sort first by the count, and then card itself. Yeah, that works. Now we don't even have to do any magic down here because we did it earlier. And in case vector, and this is gonna be our 2 pair. Exactly. Case vector 2 1 1 1 is a 1 pair. Case um, you know, high card equals exactly that. And that high card. How are you breaking ties? Right here. So, like my three of a kind has just all of these in, well, let's say look at two pair. So this card here is the higher pair. This is the lower pair, and this is whatever is left. And in this case here, these three, these are already in order because I sorted this list. First, I like grouped the cards by their counts, and then I sorted them first by the counts, and then secondary by the value of the card. Right. So that might break down if there's like a straight or something, but in this case, that works perfectly. Okay, and then now the ordering for everything is just going to be, these three, four, whatever, all these members as a tuple. Card isn't any. No, 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 no. Card groups. This is a list of card and oh, wait. This is not a vector. Okay, card two. Found card and card. Required just a card. Oh, four kind. Let's look at our four kind. Case. Oh wait. Case four kind. Card, and then here's a tiebreaker. There's a tie card in there too. Okay. And a list required a vector. So two vector right here. And we are good to go. Okay. Now this ordering, we can nuke this completely. And well, it's still going to be an int and a list of card values. Not enough autocomplete is going to do it. There we go. Is that right though? One? I think we want five kind to be the highest. Yeah. Seven. So we'll just fix that up. 6, 5, 4, 3, 2, 1. Okay. That works. Cards is a vector. Cards are two list. We're converting from like list to vector back to list. What are we doing? Hi is, wait, this is just a list of these two. I don't know why I did that. Oh wait, these are tie cards. Ah, okay, right. The pair onto tie dot to list. Okay, an implementation is missing somewhere. Oh, right, yes. Now we do choose hand. Okay. Okay, we've got this. So card 2 is less than card 3. And let's try something like one pair. No, let's try 4 of a kind. Just to make sure we're not crazy. 4 of a kind. Ace. King. Oh wait, card dot ace. Card dot king. is less than 5 kind. This is hand dot 5 kind. R.2, sure. We don't have, I've got all the given implicits. Implicits, so infix ordering ops. Yeah, infix ordering ops is in here. Object implicits extends extra implicits, right? Infix ordering ops. F not found. Okay. Import map to ordering at implicits dot infix ordering ops. I guess we have to do that. Does this thing here still work? Let's just comment this out. Okay, we can do it between two lists. We can do it between two cards. Even when we comment that out, right? Oh, right. I guess the ordering has to appear. Test it here. And what? What? No way. Oh, whatever. We can sort. So here we have a sorting. It's thought all of these were high cards. D10 King 3. That isn't even enough cards. Okay. So choose hand. Test this. I'm gonna put all of this like below my enums. Let's import and dot star import card dot star. And let's choose a hand for vector 2, 2, 2. That's a 5 kind. Cool. And 1. Wait, 1 is not. Oh, wait, ace, right. Okay, it sees this as a high card. And why does it do that? Oh, wait. This ordering is wrong. So we do want to sort first by count, sure. But I think we want secondarily by, wait, what is this? Card groups. It's a list of card int. So we list first yeah, we group by the hand sizes. And we have to do a negative thing here. So the negative count followed by just a plain old card value. And we'll sort that in the right order. Yeah, exactly. Okay. It now sees as 4 kind. Great. So we have 1 pair, 2 pair, 3 kind, 3 kind, and 7 king is not as good as jack and 10. Why is it putting it in that order? I think we have to do negative on the card as well. Oh. I would have thought. Okay, so wait. Is 2 less than 3? Yeah, 2 is less than. Oh, okay. Yes, yes, the negative card as well. Okay. Now let's look at this again. Um, let's see. We're gonna do some tests here. This is this 5 of kind less than that. It should be false. It should actually say it's greater than. Wait, we have issues card. Oh, there's no negative C. So 2 followed by ace. Let's do 3 of a kind. 2 followed by king followed by ace. So they are in reverse order. We could just reverse here. Right, you could count C and then that reverse. Okay, this gives us 2 ace king. Great. And now when we look at our hands, 3 of a kind is the highest when it's a queen, beats jack, 2 paired with king, high beats. Yeah. Okay, and these will show up in the right order. Great. Sort by 1. Wait, that was this here? Okay, so we don't need to do any reversing. Sort by 1. Dot map to just a bid. Zip index. I'm not going to map to just a bid because it might be valuable to print line that card. Wait. Why are we getting? Isn't hands not empty? Yeah. Why does this end up being empty? What? What? Master1221, I just saw your message. You got this. Thank you. I appreciate your vote of confidence. I'm currently not feeling like this is got. Why would sorting it why would sorting it result in there not being anything at all? I mean, if you sort by the bid, then you should still get a list of something. You're still getting an empty list. Nope, that's not an issue you have to worry about. let's do a little test here. This should be greater than, let's say 10 as a tiebreaker. And that's true. And 333 should be greater. Then the same thing, no matter how the tiebreakers are. So let's say this is just 2 and 4, right? Oh, wait, this is still 222. Yeah. And I don't know, a 5 of a kind beats a 4 of a kind. Yeah, that's all good. That's all working. So the hands, we just sort by the hand itself. Do this 6, 4, 40. Oh, now it's working. I don't know why it was just printing empty list. And 6, 4, 40. That's what's expected. So we've got this. We've got this. Okay, we've got an answer. Oh boy, that took too long. 255. I always say that. I should say that every time. Oh no. 255 940 725. Okay, there is something subtle happening. It works in testing, but it does not work on. So let's just take a look at the hands that okay, so we're gonna map just a hand, and then we're gonna print. Fine, we're gonna print all the hands sorted, and make sure there's no fishy business going on there. Why does it do this when I sort by the first bit? Okay, let's just do. Am I getting empty lists when I do that? Hands that map 1. What? What? Okay. Case, hand, bid. That's the hand. You don't even need the case. Val X, whatever. X. What is X? Legal formal parameter for. There's very clearly two things there. If you map it to the bid, but this is a weird, it's a weird thing going on. Let's say we map hand bid just to hand bid. We get an empty list. We get an empty list when we map it. What is going on? Hands is just a list of things, right? Hands map identity. Let's map the identity function, and we get a list 345 dot map identity. Is there collecting anything? That's the only place I can see some things are being dropped. Yeah. But wait, what? Okay, look, here we have a list. All right, we map identity. We should still get the same list. And right, a list of hands. We map identity. We should get the same list. Okay, you're saying something about collect. Let's look at that. Is your collect doing anything? Which collect? Wait, do I still collect? I don't have any collects any left. You mean this match? Um, we'll leave this test up. Oh, you know, we're not gonna leave that test up. We can do list of cards. Yeah, we're cool. We're happy with that. Um, removing some noise here. Uh, but wait, this is weird, right? Okay, let's do this. List. Let's just do list to map identity. We should get the list too. Okay, list. 5 kind of 2 dot map identity. Right. And if we have a list of 2 different hands, this must be like a metals bug going on. Yeah. And you know, if we were to sort this list, we would get we'd flip those ordering. Oh, that's not the ordering I expected. It should be that's not the ordering I should be expecting, right? Let's do 4 kind 3 4. Oh, okay. Um, it's showing the lowest hands first. Let's put full house right in the middle between these two. Full house and 10, 9, sure. So this gives us full house, 4 kind, 5 kind. Okay, yeah, this is worst to best. So this is a sorted bet reverse. Oh, but why did it work for the example then? I'm just gonna comment these out. And we're just gonna do, I don't know, hand scores that sort by the hand, and then that reverse, that's if it's sum. Hand scores that sum is our answer. Let's try that. 245095775. Oh wait, but before we did the reverse, this was working just fine. Am I doing the ranks? Am I misunderstanding the ranks? So let's look at this on the example. 6640. Yeah, we're still getting the right answer. So we should reverse hand sort by blah 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 reverse sequence index. Let's just do like this, and let's print line what we're doing. Okay, the best hand is a 3 of kind with a queen, 3 of kind with a 5, 2 pair king 7, 2 pair jack 10, 1 pair 3, and all of that. And then, right, we increment that. But I can't debug this. When we're assigning to values, we're getting like weird shit. Why is it saying this is an empty list? And why is this back to Wasn't this just working a second ago? Didn't it just give us the answer? And then now it doesn't like... Is hands like an iterator? Does it become empty? Hands. Input that to list. Oh, def. Oh my god. Ah. Ah. Well, hands. We define it only once. There we go. It's because we have a fucking mutation. Oh, I can't say that on stream. Okay. Yeah, we were exhausting our iterator. That's what we were doing, and I don't know why I turned this into a def earlier. It was so I don't. Okay. Um, yeah, now this works. Now we can go back to the main thing and do some debugging. Okay. So hands, we're sorting. The best hand, five of a kind, jack. Four of a kind, king, queen, jack, 10, 8. What do we do? There are no ties in here, right? There are no ties. Four of a kind, king, queen. Yep. This is looking like a good list. So where could there be an issue? Probably there's an issue with some hand that never showed up in the test case. So let's just make sure. Yeah, we all hate mutation. I should just two lists right here. Boom. I mean, does that break things? There, mutation gone. I mean, I did it here too. Yeah, this should be my default input parsing. Okay, let's take a look at our construction of things. Tie, tie one, tie two. Honestly, like this could be, these all could have been a generic um, values iterator. What do you call it in a case class? Pair followed by the tie. Sure. 1, 2, 4, and then just the cards dot to list dot. This might be where it's happening in the high cards because this should be sorted. Dot reverse so that ace shows up first. Yeah. Did that change my answer? It probably did. No, it did not change my answer. Okay. Where? So we have a high card, two less sorted reverse. That's fine. High, dot two list, dot sorted, dot reverse. Okay. And this is always going to be the largest first. Yeah, it's because we were doing some sorting for some of these in this here. Oh, wait, I thought this was sorted, right? This, this looks like it was sorted. Oh, let's test two pair. Two pair. And no. We want to do it with choose hand. Choose hand. 2, 2, 2, 3. Well, yeah. 2, 2, 3, 3, and 4. And does it do that? This is probably where it is. Okay, so it should give the bigger thing 3, followed by 2, and then 4. Okay. I mean, that's good. Doing bigger cards first. And in our sorting, for two pair, we just take all of those elements. So we are sorting here, and we are sorting here. In all these other cases, we just take what we're given and we take it in the same order. Pair one, pair two, tie. Trip, tie one, tie two. Trip, tie one, tie two. Trip, pair, card, tie, and card. I should call this high, not tie, but whatever. And let's do vector one. You get my drift? 2, 3, 4, 5. Let's do ace. Then we're not gonna sort up, we're just gonna do choose hand. And it should start with high card. Ace, 5, 4, 3, 2. Okay. And that is fine. Right? That should be greater than maybe king, right? Oh, be greater than king, yeah. Or, you know, it should be greater than, say, 5 was instead 6. It should be less than that one. Okay, we're able to do high cards. Which which of these is problematic? The pair does not appear to be problematic. Again, two pair ends up with a list of pair one, pair two. And two pair knows to sort them first, the highest pair, the second highest pair, and then the 4, the high card. What is 245059775? We already tried that. 245 oh my god. That's it. 059. I should copy paste. I should not be typing these in. Yes, I believe that. It's not like poker. That seems to be implying that I'm doing something poker-like I shouldn't be doing. 245 059 775. That's what we just tried. And this, just to check, this still works with the example. 640. Okay. Yeah, let's look at this list. 5 kind, 4 of kind. Wait. Is that a 3 kind above full house? No, full house. 3 of a kind. 2 pair. D3 or we don't really care about which 3 of a kind you have. Oh my god. Wait, what? 3 cards have the same label? Oh, so like a king. Oh, that is cruel. Is that really the case? So how do you determine which 3 of a kind wins? They're first order on type. Every full house is stronger than 3 of a kind. Okay. 2 cards have the same type. A second ordering will take fate. Compare the first card in each hand? It's like the order that the hand is placed? Oh my god. I mean, well, that's easier, but geez. Ah, that's cruel. That's cruel. Ah, okay. Thank you for the tip, Samarth. Ah, um, that's a kind of spoiler tip that I completely appreciate. I was not going to be looking at that for another little while. And it's like, I don't know. I don't get satisfaction out of realizing that for myself. Jeez. Yep, I don't need to change much. Um, well, I do need to maintain the original ordering, right? So a hand, we just determine the hand type, which fine, we determine hand type. And then we list all the cards in order. I'm gonna change this. Uh, ordering for a vector of cards. Um, no, a hand. Oh man, I wrote all this. Okay, I'm just gonna leave that old one commented out. These are all just hands. Cards, vector of card. And hands hand, passing the cards, and cards, vector of card. Okay. I mean, honestly, we don't even need to save the cards. We just pair a hand type with, right? In fact, um, yeah, let's call it hand type. And a lot of these are gonna disappear. Yeah, whatever. We'll leave it that way. Oh, like you can have all these on one line when they're not actually like extending anything. But yeah, that works. And then ordering is just gonna be by the ordinal. Um, so hand type dot ordinal from ordinal. No, let's say like hand type dot five kind dot ordinal. Okay. Let's take this out, moving that on, and type that ordinal. Okay. We'll have to make sure. What's going on here? Ordering hand. Oh, you know, we're not gonna rename types here. We're gonna keep it as it was. This is an easier problem. Wait, ordering that on. Yeah. By. Ordering that by. And that should make five kind come first when sorting directly. And similarly for cards, to parse cards, ordering on the cards, ace comes first. We're gonna change this. We're gonna make this by ordinal as well. Ordinal. Okay. And this should make, oh, 2 is first. This will make 2 come first. We want high stuff to come first, so we're not doing any reverse. Ace, ace, king, queen, jack, yada yada. Okay. And then we have a parse card function. We'll put that below all the enums. Let's use the same syntax here. Need some stuff. And let's put that on one line. Okay. We'll put the parsing stuff below. And we have our choose hand function. I kind of should have saved, whatever. We're not saving all the old code. Cool, cool. All that work. Ordering by hand type is not ordinal. Okay, parse card. And then we choose hand type. Or, assign type. Def. Actually, I'm going to put this up right here as well. And we can remove these qualifiers. Def. Use hand. So we have a list. We're going to keep the vector of cards. Vector of card. And then we sort first by hand type. And then we sort by the vector of cards, which will be trivially sortable. Choose hand given that vector cards. And yeah. Let's see. That's all right. And that high card. So now choose hand. Choose hand, we return to cards. Oh, well, cards. Okay, yep, card string. Watch. It's going to go back to like normal poker rules for part 2. I'll have once again solved part 2 first. And then I'm gonna wish I'd saved that file, and I'm gonna have to do like a lot of undos until I get back. Okay, choose hand based on those cards. And we have the cards themselves. And then we have the bid. And wait. So we have the hands. And hands dot sort by. Case. And we're only going to sort by hands and cards. And then scores equals hands dot map. Oh wait, sorted dot map. We don't even need the hands, we just need the cards. No. Sorted dot zip with index dot map. Okay, so we have this thing going on. We have the index, and then we take the index plus 1. Bid times index plus 1. That, you know what? That was a nasty example. They could have put that thing in the test case, you know? But it just so happened that, oh, Eric, what you doing, man? You're being cruel. Okay, and 1 equals hand scores dot sum. Bid is not that. Oh wait, nope, this is no longer a thing. Yeah, scores. Yeah. Do we have another issue here? Ambiguous given instances. Both given ordering card and in black. Apply to what? Wait, why is there a dot hand type? That ordinal should be fine. Yep. Okay. I'm pretty confident in that. I'm just gonna type it in. 244 551 934. 551 934. Well, we typed that in right. But still, if we're still getting the right answer for X. Six 640. Okay. So it's like we're always using high card rules to determine what wins. Each hand wins an amount equal to its bid multiplied by its rank. Let's see here. Oh my god. 5 hands. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank. Where the weakest hand gets rank 1. The second weakest hand gets rank 2. Sure. How do we break the ties again? Oh. 6440. Okay. Thank you for catching that. Okay. Let's look at these hands sorted then. So, our best hand is a 3 of a kind, Queen, Jack, Ace, 483. And that's what we're seeing. Oh, no. That one, 483, is being multiplied by 5. Oh, I have them sorted Wait, why would that one? Queen, 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 jack, ace. Why would that not be... That is the best hand, right? So it's coming up first in my list. Am I misunderstanding the ranks? Rank 1 is not the best one. Okay, so multiply by its rank, where the weakest hand gets rank 1. Oh, okay, the weakest hand gets rank 1. Great. Well, I'm just gonna change my ordinal. Ordering by negative ordinal. Oh, hold on. We still want the best. Yeah. Okay. Now we got 6440. This should be it. 256448566. I have 30 seconds to wait. 1 minute, 30 seconds to wait. 256448566. Excuse me. So let's look at these. We start with a bunch of high cards, and this one starts with a 2, so of course it would be rank 1, right? This is looking correct. And then we're getting to 1 pair, 2 pair. Okay. And let's just make sure. So these are both forward kind hands. I want to just make sure they don't have a silly rule like, oh, this is not 2 pair because the 10s are not together. Okay, those are both 2 pairs. Okay, cool. Okay, I'm gonna try again. 11 seconds left to wait. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I did hesitate backseating. Did that a while ago. I don't know. I don't know why the things aren't showing up on screen. But we are going to go to part 2. And make things a little more interesting, the elf introduces one additional rule. Now, J cards are jokers, wild cards that can act like whatever card that would make the hand the strongest type possible. Balances J cards are now the weakest. Okay. The weakest individual cards. J cards can pretend to be whatever card is best for the purpose of determining hand type. For example, okay. That we can do. So, Jack is now a joker. You know what? While I'm right here, I'm gonna omit just part 1. So 2023, day 7, part 1. Um, Jack is now a joker. And comes first in this list. And now, when we're choosing a hand, so there are some cases here. Anything as a joker, they should all probably become the same thing at the same time. So if you have multiple jokers, right, like this one here, now we end up with 2 10s. Um, Uh, we can kind of leave this part here and do like a transformation before that. Oh, thank you for the follow. Thank you for the follow. I can't pronounce your name. And Chessmaster, I see you followed too. I appreciate it. Okay. I'm thinking here. So let's say there is one joker here. We check if this card 2 is a joker, and then if so, we assign this a 5. If the card 4 is a joker, then it doesn't matter. In fact, if either of them are a joker, then we do that. Nick. All right. Well, welcome, Nick. So if card equals joker or card 2 equals joker, then 5 kind, else 4 kind. Okay, so we haven't had to change much there yet. If you have 5 jokers, that's that. Um, but now, okay, yes, yeah, this is fine. So card 3 and 2. So if either of those are a joker, I think this kind of logic still continues to work. All right. Else full house. And this is where it starts to get interesting. So if card is a joker, then we have actually a 4 of a kind. Else, if card 2 is a joker, the joken is a joker. Or, yeah, or card 3 is a joker, then we get a full house because it can just become the other card. Yeah. ChatGPT. No, it's not ChatGPT. Copilot, GitHub Copilot. Otherwise, it's just a normal 3 kind. And here we go. Else, else then, else if. It's not like something here. Joker is not imported. Oh, parse card. We also need the enums. So Jack goes to the back of the line here as a joker. Okay. So if card equals joker, then then we have 4 of a kind. If either card equals joker, then we have 4 of a kind. Card 3. So I don't even have to think. Okay, and then here, this is a 2 pair. So card is a 2 pair. So if card equals joker, we have a 3 of a kind. Otherwise, if any of the others are jokers, then we also have a 3 of a kind. 2 pair? Why would you want 2 pair? No, you'd want 3 of a kind because you can become a 3 of a kind by joining a single pair. So, Copilot was wrong here. Oh, basically, if any card is a joker, then we have 3 of a kind. So let's do that. Or let's do this. If set card 2, 3, 4 contains joker, then Then this is a 3 kind, else 2 pair. And in this case, we'll name this cards. If cards that contains a joker, then 1 pair. Else. Wait, what's going on here? Card that contains joker, then 1 pair, else high card. Okay, I'm happy with that. 2, 5, 4, 7, 5, 8, 6, 6, 1. 2, 5, 4, 7, 5, 8, 6, 6, 1. Let's try this on the example. Else 1 pair. Line 59, else 1 pair. Oh, yes, this was still 1 pair. Thanks for catching that. Okay, let's still check it against 5905. I mean, I guess it doesn't even show up in the example. This is a terrible example. There should be more cases in that example. Okay. So let's change it back. And do I have to wait 5 minutes? I have to wait 5 minutes, don't I? I might have to wait 5 minutes. 254 470 470 339. Two five four 470 339. So this is how we get 1 pair, else. Oh wait, this is a high card. Could become a 1 pair. So 1 pair, it could become a 3 of a kind. A 2 pair and become a full house. It could potentially become a 4 of a kind. And a 3 of a kind could become a full house. Can always become a full. Wait. No, it can become a 4 of a kind as well. Yep, it's there. Okay, full house or 4 of a kind. And a full house can become a 5 of a kind. A 4 of a kind can upgrade to 5 of a kind. And a 5 of a kind doesn't matter. I mean, that all looks good. We are working correctly with the example. And I trust most of the rest of the code that didn't need to change from part 1, right? 5905. Okay, did anything else change about scoring rules? It's still only 1 pair. Doesn't get, okay, its strength doesn't increase. Is now the only 2 pair, making it the second weakest hand. Yeah. These are both now 4 of a kind. Yes. Yeah, these are all 4 of a kind. And to determine the ranks here, and we were able to sort those ranks out properly just fine, right? And we can do this like Jack is less than 2, or Joker rather. 1 pair is less than 2 pair, just making sure, whatever. Wow, I don't know where that is. 254 470 339. Hmm. Um, we're still we're still parsing fine. These orderings, these enums are still fine. The only place where there's any logic is right here. Need to change line 51, but I didn't change it. Oh, okay. So if card 2, so this is the apparent 3 of a kind case. And if a card 2 is a joker, we can turn that to a 4 of a kind. A 4 of a kind is better than a full house, so we would turn it into a 4 of a kind. Oh, yes. Yep. That's it right there. Um, this is another case where there's an apparent 3 of a kind here, and it's not caught in the example because the example is like way too small. Oh my god. 76 cents. Thank you for the follow. Okay. Okay, we've got it now. So 254, 262. How many times have I said that? We've got it now. 965. No. Okay, we don't got it. Um, so if it's an apparent 3 of a kind, then any card in there turns into a 4 of a kind, right? The jokers can match with one of these can match with the joker. If it's apparent full house, we can turn into a 5 of a kind. In fact, we could write something much like this: if set contains joker. Oh, you know what? In fact, we could just write this way: if cards contains joker, then we have a 3 of a kind. And same thing here. If cards contains joker, then 5 kind, else 3 kind. And again, if cards contains joker, then 5 kind. This is a little bit easier to read and debug. Put the else in the other row. So this is apparent full house 3-2, apparent 3 of a kind with a 1-1, or 3-1-1 rather. Okay, let's check this one here. If if either of these 2 cards are jokers, we become a 4 of a kind, right? And if the remaining card here is a joker, best we can get is full house because it matches up with one of these. Card 3 is joker. Otherwise, we stick at 2. Yeah, I'm happy with that. And again, we can say if cards contains joker, then 5 kind. All right. This is very easy to read. And in reading it, I'm not seeing the bug. Let's look at how this sorts. A high card with a joker first ends up losing. Makes perfect sense. And we get a 5 kind. Did we ever get a 5 kind in the first set? I don't think we might not have. I don't think we did. A 5 kind with the joker and aces is the best. So that seems to be working. Oh, you know what I'm gonna do? I'm gonna filter some of these. So we're gonna do the sorting. But first we're gonna filter, not filter. Um, oh, you know what? This is a case where I should use a named tuple. So I can just reference cards instead of _2. _2. In fact, yeah. I have to read up on name tuples and how to use them, so I can just more fluently go into that. Filter that contains Joker, and this contains is looking for cards, right? That's right type. So these are only cards that have Joker, and here we have a 5 of kind, and we have a 4 of a kind. Wait, why is this a 5 kind? Joker 4 4 4 3. That can't be a 5 kind. Joker 4 4 4 3. No. Joker 5 5 5. That is a 5 kind here. What else is going on? Wait, these are all 5 kinds. Joker 3 3 9 3. I think I wrote 5 kind instead of 4 kind somewhere. Oh, right here. I think that was formerly 4 kind when I first submitted it, though, right? Oh wait, no, this becomes a 5 kind. Yeah, this becomes a 5 kind. That was okay. That's for what case? That's for like something that looks like a 3 of a kind. Okay, this is ace ace king ace joker. This is an apparent 3 of a kind, and it should become a 4 of a kind. There's no way from the apparent 3 of a kind. Here we go. 3 1 1. If anything contains a joker, and this is a 4 kind right here, right there. We found it. Okay, 2 5 4 2 6 2 9 6 5. But okay, that's a bug written during refactoring. Okay, so let's look at this again. This is a 5 kind. This is a 5 kind. No. We just want the ones that contain joker. Joker. Yeah, 5 kind. 5 kind, 5 kind. Sure, 5 kinds are looking good. 4 of a kind. Queen 2 2 2 joker. Right, it's a 4 kind leading with a queen. Yeah. Okay, our 4 kinds are looking good. Our full houses are looking good. Queen, joker 9, queen 9. Yeah. And it doesn't matter whether joker becomes a queen or a 9 in this case, because we judge it first by the queen, then the joker, etc. Okay. It is always treated as jack and not the card it's as a joker and not the card it's pretending to be. That's what I'm doing. We're treating it as the joker, as the weakest card. Purpose of breaking ties between two hands, the same type. Okay, for purpose of breaking ties. That's good. It just changes the hand type. That's true. J cards are jokers. Oh my god, I'm not seeing it. I'm not seeing it. 905. What else can we look at? We can construct some sort of example. Um, if we construct an example, we also have to calculate the score. What we could do is do a bunch of 0 bids and then like a 1 bid somewhere and see if that gets the right rank. Well, honestly, as long as it's sorted properly, then we are good. Let me take a closer look at the high card hands. So here, containing only Joker. Wait, what happened to my print log case? Oh, we don't want this. We want the full deal. Okay. High card. All these. Wait. Why would a high card hand ever have a Joker in it? Joker 2, 6, Ace 9. That should become a pair. If cards that contains a Joker, then 1 pair. Else high cards. Right? Like this is the remaining case. Oops. So there's a bug somewhere. Raython, welcome to the chat. Haste2 squared, I want to ask a question. I need my child to be programming literate and want to take your advice for where you can get the best tutorial for Emacs and Spacemacs versus DoomMax. Well, I assume starting them off with Emacs is a joke. Honestly, teach your child Vim. It's what's hip these days. There are no good tutorials. There are tutorials. The info pages. You go info Emacs, and these man pages are it. Wait. No, these are not the info pages. Emacs is the best tutorial for Emacs. You go in there and you open up the manual. I know it might be like MX manual, MX info pages. The very comprehensive manual. Can't believe I recommended Vim over Emacs. I think it's understood. I'm joking. I say that. Yeah, still going the laborious way. Okay, let's look at this again. High cards. This should not be called a high card. There is a Joker in here. There's a Joker in here. This is a 1 pair. What's going on? So this is this very last case. So high card can only happen here. If cards that contains Joker. Oh. I shadowed. We can underscore. There we go. It's not going to contain a Joker. This right here contains is not type safe. Joker wasn't even the right type. The cards being shadowed here was a tuple. That I need to lint for, and I can lint for it. I need to add that to my build settings. Okay, now it's 1 pair. Great, this is my answer. This is really it this time. 412181. What'd I say? That was it. Oh, contains got me again. Okay, I'm gonna get wart remover. I'm installing a wart remover before next session, and we are never gonna have that mistake again. Right there. I mean, it was the least of my troubles. tonight, but still. I know I might be missing out, but I don't know how anything can be better than Vim's modal editing and text objects. I mean, Vim's modal editing is probably great. I I'm just stuck with my Emacs GNU readline key bindings. And you know what? They show up everywhere. If you're on a Mac, you have GNU readline bindings in your web browser, the terminal. Um, geez, that's that. Oh my God. Now, when did I notice? I spent the whole hour, the whole first hour, not realizing that this doesn't follow like poker rules for tie for tie breaks. And I was just bugging. Ah, the issue with contains. So the issue with contains is that you can write this list 3456 dot contains 7. Right. This is not a type error. And that's what I had going on here. I wrote cards here, shadowing my card's parameter. And this card here is a list of card and int of tuples. Meanwhile, this here is a vector of card. So that was it right there. Yeah, I need to lint for that. And you know, let's pull this up. Wart remover .org. Oh boy, I'm sorry, that's bright. Um, nope, nope, nope. That's it. Alt Shift A. There we go. Sorry about that. That's probably burning someone's eyes. Milton warts contains. It doesn't have a wart for contains. No. Okay, I mean, I should just avoid using contains. Do it in some other way. That exists. Something equals Joker. Typesafe contains has been discussed a lot within the Scala community because you're new think to make it. So it's 2023 and it's still a problem. And it's because of variance, right? You have you know, you can compare it with any like super type. So then it just turns them both into a super type and it does a comparison in that. Um, you can't fix it in here. It's just by nature of the function contains, right? Like it has to be covariant in this type parameter here in the A1 in that upper bound. Right? Because you have to um let's say, you know, you have dog and you're passing in an animal, you're checking if that animal is contained in the list of dogs. Well, you can do that because that animal might be a dog. So you have to be able to lift it up. And maybe there's, I don't know, this is discussed in the forums. There's other way, and you know, like some libraries have like contains methods that work more nicely, I think. I can't remember. It's been probably a few years since I've read up on those threads. Anyway, we're gonna commit that. Part 2 as solved on stream. Oh, what a sad way to lose an hour. I'm probably like top 5,000 again. Or like over 5,000, I mean. Yeah, this took way too long. Once I got it, it took me 30 minutes to get part 1. And 30 minutes would have been like certainly less than 5,000, right? Oh, my reading comprehension. Here's the way I could have expected that. I could have been like, well, he's writing a problem. People might already have like poker card, whatever, as a library. And if they do, we don't want them to be able to reuse that. So let's change up the rules a little bit. So I should have been wary of that. Yeah, the mutable error, that took me back like, I don't know, maybe 5 minutes. I was still debugging stuff as I went with that. It just meant like I couldn't test anything for a while. But yeah, the mutability error, the contains, there were lots of things. But you know what? That's a good thing. This here is it's a gold mine of mistakes. And what I want to do is catalog all of these mistakes, or catalog all these things that slowed me down, and talk about, how can you fix these? How can you avoid each of these types of errors in reasoning, in problem solving, in programming? In some cases, your compiler can help you. In some cases, it's linting. In some cases, maybe like a checklist. When I'm reading a problem, I should have a checklist, like check conditions, check if potential assumptions are wrong. Yeah. So this is worth examining, and I want to think about it. Write up you know, perhaps I'll become like a YouTube video that I'll put out on my YouTube channel once I've collected a lot of these mistakes from this year's Advent of Code. So it's not the worst thing in the world. You know, I complain a lot while I'm doing it, but I'm still having fun. It's fun to curse Eric. Ah, what was it? Day 5. You put dest before source. And that got me. I was like, oh, he goes source to dest. Zombie shoe. Hey, welcome. I remember, didn't Midnight Simon raid you yesterday? Thank you. I appreciate it. At least the code's nice. I'm happy with the final code. Right. This thing here, Copilot can auto-complete that. So this is my first year using Copilot and learning what can be auto-completed pretty reliably. Copilot was able to auto-complete like this list here. Ordering by ordinal, very, very easy to do. And then, I'm able to just rely on the. So this is a case where Scala's type inference shines. And in fact, maybe I'll show a different problem. So what was it, day 13? So Scala's type inference is not just type inference. Oh, Raython, thank you for follow. Look at this. So here we had packets. They were weird. Let me see if I can pull up the file. So it's 13, 2022. This kind of thing, right? Lists of numbers and other lists and stuff. It's either a packet list or a number of some sort, right? And here I give it an ordering of a packet. So this is a given. It's an implicit that gets used in methods that need an ordering, right? So if you're sorting, you need an ordering. This will automatically get used because it's sort of the canonical ordering of a packet. Now here, inside of an ordering, I use an ordering of a seek of packet. And at this point, so this is recursive. This is inside the definition of the ordering for a packet. We use a definition of ordering for a seek of packet. And because there's an ordering for a packet, we know how to sort a seek of packets. So we're able to construct that automatically. And in fact, if you can see the definition, oh, I don't know where to find a definition. But yes, the ordering, I don't know. There's a method that gives you an ordering of a seek of packet of a seek of something generic, and then it searches for type, right? So like this thing is kind of inferred to the max. It's derived, right? So Scala inference isn't just inference, it's derivation. And we didn't have to write an ordering for seek of packets. Whereas many people this day did have to write extra code to figure out how to like compare the list or whatever. Or I don't know. I suppose I could convert it into a list of integers and maybe like they already have a way to sort that. But why was I saying that? I guess I was just saying I'm happy with the code. It's nice to have these orderings here. And all the logic is right here, not too bad to handle. Okay, I'm not even gonna bother leaving ends one in there. Let's commit this. Oh, we already commit. Let's push this. Whoops. What's going on here? That's weird. Okay. All right, there we go. And I'll leave my GitHub in chat if anyone would like to go over any of my code. And here's my leaderboard, which I'm about to pull up. I've probably dropped more ranks here. I've dropped from 5 to 6. Yeah, this is an easier problem than I made it. But at least I got there. The thing I know is I know I'll make it all the way to the end. Not everyone ahead of me might make it all the way to the end. So I might be slow, but I'll be persistent. Slow and steady. And I'll have some days where I'll shine. If we ever have like an interpreter day, then I'll do well there. Or like a DSL type thing. Like that day 13 one I just showed you. That one was an easy one for me. Like relatively. A lot of people didn't do part 2 yet. Interesting. How did I do on Delta time? So for Delta rank, I am higher than my 15. I guess I'm happy with my Delta time. There were some little bugs in here. And what was it? The contains bug. This was hard to find. Because I trust this method too much. That should be added to my like debugging checklist. Did you use contains? Did you use set.map? And I should reference a checklist until I have it internalized, and then maybe that will make me faster, smoother, better at debugging next year. We'll see. Anyway, I think that is enough for me. By the way, I'm just gonna plug my Discord over here. If you'd like to chat offline about any problems Scala have in the code, that's where you can find me. And with that, let's find someone to raid. So Twitch, Advent of Code. Juicebox Hero is still on. Oh, you know who's missing? Oh, Alka is still on. But Alka finished. Um, who's that's why this page doesn't looks different. Time enjoyed is not on. Let's take a look at Juicebox Hero. I don't believe I have rated them yet. So let's do that. Juicebox Hero. Oh, this channel is for mature audiences. Warning. Okay, well, thanks everyone. Have a good night. Say hi to Juicebox. Oh, I have to stop streaming. Okay. Good night.